I am B. Spandana from second year CSCA. Today I am going to discuss about Peterson solution in process synchronization. First, what is Peterson solution and how it is solved? Peterson solution is used to solve critical section problem. Critical section problem is only one process can enter into its critical section at a time. It can be solved by using Peterson solution and semaphore solutions, monitor solutions. Today I am going to discuss about Peterson solution. Peterson solution problem can be solved using producer consumer. That is, describe two processes, the producer and the consumer, which share a common fixed size buffer used as a queue. Producer produce an item and put it into the buffer. If the buffer is already full, then the producer will have to wait for an empty block in buffer. Consumer consumes an item from buffer. If buffer is already empty, then consumer will have to wait an item in the buffer. Implement Peterson algorithm for two processes using shared memory such that there is mutual exclusion between them. The solution should have free from synchronization problem. Let us discuss a piece of code for producer and consumer problem. This is a piece of code for producer problem. To produce an item, first we have to initialize the flag value to true so that the process can enter into its critical section. Turn value equals to I. Turn value can tell that the process can enter into a critical section or not, and which process turn it is to enter into its critical section. After initializing two values, we have to check the condition while flag of I equals to true and turn equals to I. If the process satisfies these conditions, then the process cannot enter into its critical section because there is already another process in the critical section and using the shared resource. So that the current process have to wait until that process will execute its program. After executing its program, this program can enter into its critical section and use the shared resource that is also known as buffer or queue. And after using this buffer resource, it will come out of the critical section and initialize the flag value equals to false so that another resource or another process can enter into its critical section and use the buffer without any problem. Let us discuss the code for consumer. Code for consumer. First, we have to initialize the flag value and turn value. Flag value equals to true so that the consumer process can enter into its critical section, and turn equals to j so that it can tell this process turn it is enter into its critical section. After initializing these two values, we have to check the condition while flag of j equals to true and turn equals to j. If the consumer satisfies these conditions, then the consumer cannot consume any item and it has to wait until it's consuming any item. After the completion of its waiting, it can enter into its critical section and consumes the item. And after completion of its consumption, it can come out of the critical section, initializes the flag value to false so that another consumer process can enter into its critical section. Clear explanation of Peterson problem. Peterson algorithm is used to synchronize two processes. It uses two variables, a Boolean array flag of size 2 and int variable turn to accomplish it. In the solution, I represents the consumer and J represents the producer. Initially, the flags are false. When a process wants to execute its critical section, it sets its flag value to true and turn and the index of the other process. This means that the process wants to execute, but it will allow the other process to run first. The process performs busy waiting until the process has finished its own critical section. After this, the current process enters into its critical section and adds or removes a random number from the shared buffer. After completing the critical section, it sends its own value to false, indicating that it's not wish to execute anymore. The process runs for a fixed amount of time before existing. This time can be changed by value of the macro RTR. The brief executive about Peterson problem is that to solve the Peterson problem, the process can have to enter into its three sections. The first section is entry section. The process has to enter into its entry section and checks the process is ready to enter into its critical section or not. If the condition satisfies, then the process can enter into its own critical section and use the shared buffer. After using the shared buffer, the process exits its critical section and comes into exit section. In the exit section, there will be a piece of code which initializes the flag value to false so that another values can enter into its critical section. This is also known as Peterson problem to solve the critical section problem. Thank you everyone for giving me this opportunity.